2019 August, Combined Maths 1, Calculus, Drawing Graph. Let fx is equal 9 into x squared minus 4x minus 1 over x minus 3 to the power 3 for x not equal to 1. Show that f dash x, the derivative of fx is given by f dash x is equal minus 9 into x plus 3 into x minus 5 over x minus 3 to the power 4 for x not equal to 3. Sketch the graph of y is equal fx indicating the asymptote, y-intercept and the turning points. It is given that f double dash x is equal to 18 into x squared minus 33 divided by x minus 3 to the power 5 for x not equal to 3. Find the x coordinate of the points of the inflection of the graph y is equal fx. Answer for this question. The function fx is given 9 into x squared minus 4x minus 1 over x minus 3 to the power 3, x not equal to 3. F dash x, derivative of this function, is equal, here in the denominator, x minus 3 to the power 6, that means square of the function, square of the denominator of this function, x minus 3 to the power 6. In the numerator, x minus 3 to the power 3 into derivative of this numerator. Our 9 is a constant, 9 into, inside the bracket, this one 2x minus 4. Minus, into numerator, minus, into numerator 9 into x squared minus 4x minus 1 into derivative of this denominator. Derivative of this denominator is equal 3 times x minus 3 to the power 3 minus 1. That means 3 into x minus 3 squared. When we simplify this further, cancel by x minus 3 squared, both numerator and denominator. Therefore, this is equal x minus 3 into 9 into 2x minus 4 minus 9 into x squared minus 4x minus 1 into 1 of the 3. Denominator x minus 3 to the power 4. This one, expanding this bracket, 9 into x into 2x, 2x squared minus 6x minus 6x minus 4x, they have minus 10x, minus 3 into minus 4 plus 12, minus 9 into 3, 27 into x squared minus 4x minus 1 over x minus 3 to the power 4. This one, 18x squared, 18x squared minus 27x squared minus 9x squared. This one minus 90x. This one 27 into 4, 54, 108. 108x. 108x minus 90x plus 18x plus 135 over x minus 3 to the power 4. This one minus 9 out of the bracket, x squared minus 2x minus 15 over x minus 3 to the power 2. When factorize this one, minus 9 into x plus 3 into x minus 5 over x minus 3 squared. This is the f dash x. F dash x is minus 9 into x plus 3, x minus 5 over x minus 3 all things squared for x not equal to 3. The graph, now we investigate about the asymptote. Two types of asymptote. One is vertical asymptote, other one is the horizontal asymptote. Now vertical asymptote. So how to get the vertical asymptote? This is the function we are given. Fx is equal 9 into x squared minus 4x minus 1 over x minus 3 to the power 3. This function fx is not defined at what x value? In which x value the function is not defined. Therefore, the denominator should be 0. Therefore, at x is equal 3, this function is not defined. Therefore, x is equal 3. X is equal 3 is a vertical asymptote. Okay, now I draw the x is equal 3. This is the x is equal 3. This is the vertical asymptote. X is equal 3. X can approach 3 from both sides. From this left side or in this right side. X can approach 3 in two sides. As x approaches 3 from left side is known as the left hand limit. So what is the left hand limit? So we want to find out the value of fx as x approaches 3 left hand side, left hand limit. To find out the left hand limit, one of the rule is there. We already learned the left hand rule. This is the rule to find out the left hand limit. The left hand limit, we just put 3, consider one of the value h, that is tends to 0. Substitute 3 minus h for x. The function x, in the function x, we want to substitute 3 minus h. Here limit h tends to 0. Then we want to take the limit h tends to 0. This is the left hand limit. Okay, here limit h tends to 0. 9 into x squared for x 3 minus h all things squared minus 4 into x, therefore minus 4 into 3 minus h minus 1 over for this x 3 minus h 3 minus h minus 3 to the power 3, this one. Then when simplify, h tends to 0, therefore here this one 0, this h 0, therefore 9 into 3 squared 9, this one minus 12 minus 1 divided by 0 plus 3 minus 3 cancel, here minus 0. In the numerator, this one minus 36, denominator minus 0, therefore this one is a infinitive. Therefore left hand limit here, left hand limit is infinitive. This is the portions of the graph. One part of this graph we can draw this one, left hand limit. This one, left hand limit. As x approaches 3 from left side, the function approaches, function is plus infinitive. The function is plus infinitive. Okay, now we consider the right hand limit. As x approaches 3 from right hand side, that is known as the right hand limit. So this is also, we can use the rules to find out the right hand limit, that is this one. For the left hand limit we put 3 minus h, for the right hand limit we put the 3 plus h. That is the difference. Limit h tends to 0 आगा, the function 9 into 3 plus h all things squared minus 4 into 3 plus h minus 1 over 3 plus h minus 3 to the power 3. Then h tends to 0, therefore this one 9 into 3 squared 9 minus 12 minus 1 over here 0. This one minus 36 over 0 minus infinity. Therefore, right hand limit is the right hand limit as x approaches from right hand, as x approaches 3 from right side. That is the right hand limit. Therefore, this right hand limit is minus infinity. Here minus infinity. Therefore, we can show this is in the graph, part of the graph. Positive x approaches 3 from right hand side, the minus infinity. Therefore, we draw like here. The figure. X is equal 3. This is left hand limit. This is the right hand limit. X is equal 3 is the asymptote. Okay. Now, we consider the horizontal asymptote. How to find out the horizontal asymptote? Fx is equal 9 into x squared minus 4x minus 1 over x minus 3 to the power 3. As x tends to plus infinity, so what about fx? Fx is equal, this one also infinitive, denominator also infinitive, therefore this one tends to 0. As x approaches plus infinitive, fx approaches 0. As x approaches minus infinitive, what about fx? Fx also approaches positive. Therefore, y is equal 0 is a horizontal asymptote. Y is equal 0 is the x-axis. Therefore, this one also horizontal asymptote. As x approaches plus infinity, as x approaches minus infinity, fx approaches 0. Therefore, we can show this in the diagram. This one. This is a vertical, this is a horizontal asymptote. As x tends to approaches minus infinity, function tends to 0. As x tends to plus infinity, function tends approaches 0. The horizontal asymptote y is equal 0. This is the vertical asymptote x is equal 3. Now, we will investigate about the turning points. So, f dash x is equal minus 9 into x plus 3, x minus 5 over x minus 3 to the power 4. We already calculated. So, f dash x is equal 0 for maximum or minimum. Therefore, x plus 3 into x minus 5 is equal 0 for maximum or minimum. Therefore, x is equal minus 3 or x is equal 5. So, critical values are minus 3, 5 and 1 more values and x is equal 3. At 3 also the function not defined. Therefore, three critical values, -3, 3, 5. Now, we want to investigate the sign of the f dash x in three ranges, in four regions. When x less than -3, when x lies between -3 and 3, when x lies between 3 and 5, then when x greater than 5, what about the sign of f dash x? We want to investigate this one. Okay. This one first we want to investigate. X lies between -infinity and -3. X lies between -3 and 3. X lies between 3 and 5. X lies between 5 and infinity. We want to find out the sign of f dash x. Sign of f dash x. To find out the sign of f dash x in this range, we want to find out one of the values in this range and substitute in f dash x. Okay, here we want to consider one of the values in this range, -infinity and -3, say -10. So -10 we substitute here in the f dash x, -10. Therefore, -9 into this one -10. -10 plus 3 -7. Here -10 -5 -15. Over this one -13 to the power 4. Therefore, minus divided by plus. Therefore, this is negative. Now, we want to find out one of the values in this range. In this range, one of the value for an example, x is equal 0. Now, we substitute here, x is equal 0. And put x is equal 0, this one -9 into 3 into -5 over x is equal 0, therefore -3 to the power 4, that is the 81, therefore that is positive. Now we want to find out one of the value from here to here, between 3 and 5. For an example, x is equal 4. When substitute here x is equal 4, this one -9 into 4 plus 3 is 7 into 4 minus 5 minus 1 divided by 4 minus 3 to the power 4. We have this one positive. And now here we want to find out one of the value between 5 and infinity, for an example 10. So put the 10 here. -9 into 10 plus 3, 13 into 10 minus 5, 5 in the bottom part. 10 minus 3 is 7, 7 to the power 4. So positive. Therefore, negative divided by positive. Therefore, here that is negative. So here negative means f dash derivative of f(x) is negative. Therefore, the function f decreasing. Here derivative of the function positive. Therefore, function here increasing. Here also function increasing. And in this range, function decreasing. So at x is equal -3, consider x is equal -3, function at x is equal -3 at neighborhood. At neighborhood of -3, function decreasing and increasing. Therefore, at x is equal minus 3, function has what is the decreasing and increasing minimum. So we want to find out the minimum point when x is equal minus 3. What about y value? So we want to substitute on the function f here. When substitute for x is equal minus 3, we can get the y values. So when x is equal minus 3, this one 9 into inside minus 3 square 9 minus 4 into minus 3 plus 12 minus 1 over minus 3 to the power 3. This is minus 5 over 6. When x is equal minus 3, y values are minus 5 over 6. Therefore, minus 3, minus 5 over 6 is the minimum point. Therefore, minus 3, minus 5 over 6 is the minimum point. Now, we can mention in the diagram the minimum point. Minus 3, minus 5 over 6. Minus 3, minus 5 over 6. Might be here. So this is the minimum point. And here we can make like this for minimum point. This is the minimum point. At x is equal 5, what about, because at x is equal minus 3 and 3. Therefore, what about x is equal 5? At the neighborhood of x is equal 5, increasing and decreasing. Increasing and here 5, therefore increasing and decreasing. Therefore, at x is equal 5, fx has a maximum. Now we want to find out the maximum point by substituting here. When x is equal 5, what is the y value? When x is equal 5 here, 9 into 5 square 25 minus 4 into 5 20 minus 1 over 5 minus 3 to the power 3. This is 9 by 2. Therefore, 5, 9 by 2 is the maximum point. 5, 9 by 2 is the maximum point. 5, 9 by 2, maybe here, 5. 5, 9 by 2, 9 by 2, 4 and a half. 4 and a half here. 5, 4 of this one. Might be here the maximum point. So here approximately we got some idea for the graph. Here graph approaching, here approaching this line, here approaching this line, here minimum value, here maximum value. Therefore, I think we can draw the graph approximately. And also one more point, intercepting point of y-axis also we can find out. To get a good graph, we want to find out the y-interception. To find out the y-interceptions of point, we substitute x is equal 0 in the function fx here. The function fx, we can put x is equal 0, then we can get the y value. When x is equal 0, this one 0, this one 0, this one minus 9 over minus 3 to the power 3. Therefore, this one 1/3. Our y-intercept is a 0, 1/3. 0, 1/3. Maybe here. The y-intercept. Now we got 3 points. Here one of the minimum point. Here one of the maximum point. And this is the intercept point. And the approaching part of the graph. Here approaching, here approaching, here approaching this line. Here approaching the x-axis. Now we will draw the graph. Just watch the graph. Now we draw the graph. Okay, here coming is the minimum point. Here intercept. Going here. Then in this way coming maximum point and approach is the graph. Okay. Then I draw it again. Minimum point, intercept, then approaches here. And we can zoom this graph like this one. When zoom this graph, we can clearly observe the minimum point and maximum point. Here is the minimum point, 3, minus 3, minus 5 is the minimum point here. And maximum point, we can observe here, maximum point. 5, 9/2 maximum point. Approximate graph. Okay, next part, we are given second derivative of this function f dash x. We can find out, but we are given 18 into x squared minus 33 over x minus 3 to the power 5. This one is equal 0. When f double dash x is equal 0, this one is equal 0. Therefore, this one difference of square x minus root 33, x plus root 33 into here 18. Denominator x minus 3 to the power 5 is equal 0. Therefore, x minus root 33 into x plus root 33 is equal 0. Therefore, x is equal plus or minus root 33. Now consider this value, x is a minus infinity, the critical value, minus root 33, 3, root 33, infinity. Now we are going to investigate the sign of f dash x, sign of f double dash x. The chart. This one minus infinity to minus root 33, x lies. Here x lies between minus root 33 to 3. X lies between 3 and root 33. Here x lies between root 33 and infinity. F double dash x, we are going to investigate the sign of f double dash x. Here f double dash x is a minus. Now look here, f double dash x is minus. When you substitute one of the value here, f double dash x is a plus. When substitute one of the value between 3 and root 33, f double dash x is minus. When substitute one of the value root 33 and infinitive, f double dash x is equal positive value. Now concavity, consider the concavity. This one minus, they have a concave down. This one concave up. A concave down. This one concave up. At x is equal minus root 33. Minus root 33, have a look. Concavity changes. Concavity down to up. So concavity down to up means, that means down to up. Therefore, this is an inflection point. At x is equal minus root 33, there is an inflection. And also, at x is equal root 33 also, concave down into concave up. Concavity changes from down to up. Therefore, at x is equal 33 also, inflection point. There is an inflection at x is equal root 33. So, x coordinates of the points of inflections are minus root 33 and root 33.